Welcome to Flipped Classroom. We are looking at probability, and today we are looking at the language of probability. Our learning intention is we are learning about the language of probability, and our success criteria is I am successful when I can use the language of probability to describe events and calculate the theoretical probability of events. Now let's look at how this links to our other subjects, and a big thing with probability is about percentages. So we need to remember that percent means per 100, and to convert percentages into fractions we just need to divide them by 100. So here is a table of common percentages and their fractions and their decimal notation. We will look further into this when we start calculating different fractions of probabilities. So the language of probability has some specific keywords that we need to look at. When we talk about probability, we're looking at an event that is measuring the likelihood that it takes place. So we can say that that event is certain if it has a 100% chance of happening, and we call that a probability of 1. We say that an event is impossible if it has a 0% chance of happening, and we say that's a probability of 0. And any other type of event happens between 0 and 1, or 0% and 100%. The higher the probability, the more likely it will occur, and inversely, the lower the probability, the less likely it'll occur. We have some words that we use that are specific, so we have impossible, unlikely, even chance, likely, and certain. These are common words that people use when describing different events. And we put them roughly onto a number line like this. So impossible is near 0, certain is up at 1 or 100%, even chance is our 50-50 chance, which is 50% or 0.5. Unlikely is somewhere between impossible and even chance. So we usually say it's around 0.25, but it could be less, it could be a little bit more. And likely is anything more than 0.5, but less than 1. And so we have a couple of questions here that we'll use as an example. We have a scale over there from 0 up to 1. You need to put on to this probability scale the probability that you will sleep tonight, the probability that you will come to school next Saturday during term, and the probability that it will snow sometime next year in Victoria. So our thinking for all three of these is carefully reading the statement and labeling its position on the probability scale, and then provide some reasoning as to why you put it there. So for the first one, under normal circumstances, I will probably go to sleep tonight. Whether I sleep for the whole night for 8 hours or whether it's part of it, sometime tonight I will probably be asleep. So the probability of that is fairly close to certain, so I put it up near that one. The next one, it's very unlikely that I would come to school on Saturday. I might go in there to use some of the school resources such as the basketball courts or the paths, but more than likely I wouldn't be going into my school on Saturday, so I'll put that down near impossible. It's very unlikely. And for the last one, it's very likely that it will snow sometime during the year in Victoria. It's almost certain. However, there might be some changes to the weather that might cause it not to snow in Victoria, but more than likely it's fairly close to certain. That's why it's all the way up there near 100%. We have some specific terms that are used with probability, and we need to know these. So a chance experiment is a process such as rolling a dice or flipping a coin or anything that has a chance that can be repeated multiple times. A trial is one example. So rolling the dice once, flipping the coin once, that's called a trial. An outcome is what could come from that. So rolling the dice, the outcomes are 1, 2, 3, 4, 5, or 6. For flipping a coin, the outcomes are heads or tails. Now, sample space is all the possible outcomes that could happen, and we give it that special symbol. And the way we write this is we use that special symbol. So we say sample space equals, and we use the squiggly brackets to say it's the set of these numbers. So it's the set of 1, 2, 3, 4, 5, 6. We don't just write sample space is 1 to 6 because that is not precise enough. We need to know the exact outcomes. An event is the favourable outcome of a trial. and it's often represented by a capital letter. So we might say that I want all the even numbers for a dice roll. So I'll write A equals the set of 2, 4, or 6. I might say I want a head on a coin. So I would say H equals the set containing the head. And favorable outcome is the outcomes that belong to that event. So for the example before, where we were asking for even numbers, our favorable outcomes are 2, 4, and 6. So here's another example using those words. So we are rolling a dice and we want the sample space, and we want to list the events for those 4 things that are listed there. So starting off, I've got my thinking on the left and what I'm writing down for my teacher on the right. So I'm thinking the outcomes of a dice roll is from 1 to 6. So I need to write down the sample space is the set 1, 2, 3, 4, 5, and 6. For B, I need to describe that one outcome. So I will say for rolling a 4, I need the set of the number 4, and that's it. And even though it's only one number, I still put it in that set notation. For number 2, the possible events for rolling an even number, we've already said, was 2, 4, and 6. So I will write down the set of 2, 4, and 6. With the next one, we have to be careful with the language. So it says at least 5, which means 5 or more. And if I think about the dice, the numbers on the dice, the only 2 numbers that occur that are 5 or more are the set 5 and 6. And the last one is rolling at most 2. And at most means that 2 has to be the largest value. And again, looking at a dice, my only options are 1 and 2. So I write that down as the set of 1 and 2. For our reflection today, why do you think are the values of an outcome only between 0 and 1? Why can't we have something that's more than 100%? As always, like the video and subscribe for more videos on maths.